Welcome to our last lecture in Chapter 1 of Trigonometry. We're going to be looking at using the definition of trig functions to solve problems and to calculate the different trig values. We're going to look at some new identities. Our first identities, the reciprocal identities, Pythagorean identities, and quotient identities. And then we're going to learn how to kind of figure out the signs of the different function values, whether they're positive or negative, and also understanding the ranges of those values of the trig functions as well. So the first identities that we're going to look at are the reciprocal identities, and I've been talking about this as we've been going through the lecture, specifically that sine and cosecant, as you can see here, are reciprocal functions, and we saw that in the exercises that we did earlier in the chapter. Cosine and secant are also reciprocal functions, that cosine equals 1 over secant, etc., and vice versa, secant equals 1 over cosine. This means if cosine is 2/3, then secant would be 3/2, etc. And then a tangent and cotangent are also reciprocal functions. Find cosine given that secant equals 5/3. Well, as we just saw and we've seen in the previous exercises, cosine is the reciprocal of secant. And so simply what we do is we reciprocate the fraction. Here they've done it in a few more steps, but basically if secant is equal to 5/3, then cosine will equal 3/5. Find sine theta given that cosecant theta equals the negative square root of 12 over 2. Again, we have a reciprocal relationship here, so we flip the fraction and we get negative 2 over the square root of 12. However, we do need to simplify this, and we need to make sure that there's not a radical in the denominator. Well, first of all, square root of 12 can be simplified. Since the square root of 12 is the square root of 4 times the square root of 3, and the square root of 4 equals 2, we can rewrite this as 2 times the square root of 3, which you can see here. When we simplify the denominator square root of 12, we see now that we have a common multiplier of 2 in both the numerator and the denominator, which we can then cancel out. And so we get in simplified version negative 1 over the square root of 3. Again, remember, we're not allowed to leave radicals in the denominator, so we're going to need to multiply the numerator and the denominator by the square root of 3 over the square root of 3, which is really multiplying by a factor of 1, so we're not changing the value, so that what we're doing is rationalizing the denominator. And so the sine of theta would then be negative square root of 3 over 3. Now, this is again another chart. I don't like these charts. I think it's much easier if you know the fundamental formulas and then you kind of figure out, logically the polarity or the sign of each of the functional values. So here I've written in yellow just a reminder of the formulas for sine, cosine, and theta. Note that the reciprocal functions, cotangent, secant, and cosecant, are going to have the same signs as their reciprocal, because if sine is negative and flipping that fraction, you're still going to get a negative fraction for cosecant, etc. Okay, so as long as we know what's happening with sine, cosine, and tangent, well, then we can figure out the reciprocal sign. So first of all, I'm going to ignore kind of the second half of the table. I'm really ignoring the whole table because I want you to be able to think through this. Remember that sine is the value of y over r. So really with sine, we're going to look at the polarity of y. In quadrant 1 and quadrant 2, y values are positive. So the sign is positive. R will always be positive, right? Because it's the square root of, etc. It's the hypotenuse, etc. So we're really just concerned about x and y. And sine is concerned with y. So since y is positive in quadrants 1 and 2, then sine is positive in quadrants 1 and 2. In quadrants 3 and 4, below the x-axis, the y value is negative and sine will be negative. Cosine is focused on by our formula x over r. So whatever the value of x is the same as the polarity of cosine. So if x is positive, cosine is positive. If x is negative, cosine is negative. And here again, on the right side of the Cartesian system, in quadrants 1 and in quadrants 4, x is positive, so cosine is positive. On the left side of the Cartesian system, or the graph, quadrants 2 and 3, x is negative, and so cosine is negative. Okay? Now, tangent has both x and y in it. So here, and it's a ratio of those, when x and y are both the same sign, when they're both positive, then tangent will be positive. When both x and y are negative, negative divided by negative is also positive, so tangent will be positive. So notice that x and y are the same sign in quadrants 1, where they're both positive, and in quadrant 3, where they're both negative. So tangent will be positive in quadrant 1 and 3, and negative in 2 and 4, where the sine and the cosine, where x and y are different signs. And again, as soon as we have these values, we can then relate those to the reciprocals, which have the same sign as the reciprocal function. So again, I recommend that you focus on the formulas, think connecting sine to the y value and thinking about where on the graph is the terminal end, what is the value of y there. For cosine, thinking about what is the value of x. And then for tangent, where is x and y the same values, they're positive, or if they're different signs, then they're negative. Okay. Again, I'm not going to go through this table at all. We've just kind of talked about this in kind of a more functional way. The tables here, some students find it helpful to memorize the table. To me, it's always a little bit dangerous to memorize things. I'd rather think them through. It reinforces my basic knowledge, and I don't make a mistake because I memorized the wrong formula, etc. Determine the signs of the trig functions of an angle in standard position with the given measure. So let's look at first 87 degrees. 87 degrees is in quadrant 1. So this is where x is positive and y is positive. Since x is positive, cosine is going to be positive. Since y is positive, sine is going to be positive. Since they're both the same sign, tangent is going to be positive. So that means everything is positive, sine, cosine, and tangent. And if all three of those are positive, then the other three reciprocal functions are also positive. Okay? In part B, we have an angle of 300 degrees. Notice this is in quadrant 4, and it may take you a while to get used to where each of the angles falls out. Remember, we're talking about 360 is all the way around, and so 300 is in that last quadrant, or quadrant 4. Here we're on the right side of the graph, so x is positive, but we're below the x-axis, so y is negative. So here we have cosine is positive because x is positive. Sine is negative because y is negative, and because x and y are different signs, then tangent will also be negative. Okay? So sine, cosecant, tangent, and cotangent are negative. Once we had that sine and tangent, they're also reciprocals are the same sign, and cosine and its sine are both, and its reciprocal are both positive. Let's look at something a little more confusing. Here we have a negative 200 angle, and so sometimes it's hard to figure out which quadrant this will be in. So again, we're starting at the x-axis, but instead of going counterclockwise, we're going to go clockwise. So if we start at the x-axis and go down 200 degrees, notice we get 180, we're straight across, and then we have 20 more. So we're actually in quadrant 2. And in quadrant 2, x is less than 0, and y is greater than 0. We're on the left side, we're on the upper left quadrant, quadrant 2, okay? And again, we can go through this. X is less than 0, so cosine is going to be negative. Y is greater than 0, so sine is going to be positive. And then because these are opposite values for x and y, then tangent is going to be negative, and then we can do all the reciprocal values. Here it doesn't speak that same way, but you can figure those out as well. Identify the quadrant or possible quadrants of any angle theta that satisfies the given condition. So notice here we have that sine is going to be greater than 0. So this is telling us that y has to be greater than 0. Remember that sine is related to y. So since we're talking about y being positive, we're talking about either quadrant 1 or quadrant 2. However, we're also learning here that tangent has to be negative, and tangent is negative when x and y are different sides. So here we have y is greater than 0 because of the first one, but since tangent is less than 0, then x has to be the opposite sign, so it has to be negative. Well, what quadrant is x negative and y positive? Well, that is quadrant 2. Okay, they've done it a little bit differently, and you can you can read along with this and decide that as well. I again like to think again in terms of x and y and the relationship. For part B, we have cosine theta is less than 0. So since cosine is less than 0, we know that the x is less than 0. Okay. Secant is the reciprocal, and it's also negative. So it's in those same, it's that same value for cosine. Well, cosine is negative whenever x is negative, and so is secant. So x is negative on the left side of the graph, both in quadrants 2 and 3. And since these are both the only requirement, then this could be in either quadrant 2 or quadrant 3. Again, what we did here was look at x, cosine. X has to be negative. And secant, since it's the reciprocal, it's really the same. And so the only requirement is that x is negative. All right. So this is one chart I do think it's important to learn. Notice that these are basically the same thing. These are the same value, they're just in different notation. So I'm going to focus on the interval notation because I think this is easier for students to kind of see sometimes. All right, not always true, but. So for sine and cosine, the values for sine and cosine have to be between -1 and 1. Okay, so sine cannot be 1.5, it cannot be 2, cosine cannot be -2, etc. The values for sine and cosine have to be between -1 and 1 inclusive. Notice that for tangent and cotangent, they can be any value from -infinity to infinity. So there's no restriction on the range for tangent, and that's why you see here that it can be any real number. So tangent and cotangent are a real number. Now, for secant and cosecant, these have to be greater than or equal to 1 or less than or equal to -1. And you see that here. So while sine and cosine are between -1 and 1, the secant and cosecant kind of meet them. They go from -infinity to -1. They miss that range that sine and cosine have, and then they start at 1 again and go up to infinity. This is pretty important for you to know because this is also kind of a mental check. So if you get some answer that says the sine of theta is 2, you know that you're wrong because sine has to be between -1 and 1. Okay? Here's a perfect example. Decide whether each statement is possible or impossible. Sine of theta equals 2.5. Well, since sine has to be between -1 and 1, this is not possible. You cannot have a value greater than 1 or less than -1. Tangent theta equals 110.47. Since tangent can be anything, just like cotangent, this is fine. Secant and cosecant, remember, have to be greater than 1 to infinity, greater than or equal to 1, and larger or less than or equal to -1. And in this case, we have secant is 0.6. That's less than 1, and so that's not allowed, and that's not possible. Okay? So let's look at some more interesting ones. Problems. Instead of just, in the last section, we found all the trig functions when we were given the point that the terminal ray goes through, the terminal end of the angle goes through. Here we're given some information that says the angle theta is in quadrant 2, and the sine of theta equals 2 over 3. Okay? Now remember, let's find the values of the other 5 trig functions. Well, we immediately know the trig function for cosecant, right? Because it's just the reciprocal. So that's pretty much an easy one. But it can be helpful if we figure out the values of x, y, and r, and then we can just plug them in, right? We know that sine theta is equal to y over r, so we already have the values of y and r. Y equals 2 and r equals 3. If we let r equal 3 and y equal 2, as we saw in that, then we can calculate what x equals by using the Pythagorean theorem. X squared plus y squared equals r squared. And so we get x squared plus 2 squared equals 3 squared, x squared equals 5. And so x equals plus or minus the square root of 5. Now we're in quadrant 2, so what will x be equal? Will it be positive or negative? And since we're in quadrant 2 on the left side of the graph, then x is going to be equal to negative square root of 5. Once we have these 3 values, now we can calculate all the other trig functions as well. It might help you to kind of actually see it like we did the first problems. We can easily graph this with the x and y value, the y value given by the y and the r value given by the problem, given the value of sine, and then the x value that we calculated. So here we have x, cosine equals x over r, secant equals r over x. Of course, we have to rationalize. Tangent equals y over x, and again we rationalize. And then, of course, cotangent equals x over y. And cosecant is the reciprocal of sine. All right, I went through those really quickly, but we're getting a lot of examples, and it's always possible for you to pause on this slide as well. Okay. Our next set of identities are the Pythagorean identities. The first identity is that sine squared plus cosine squared equals 1. Okay? And the second is that tangent squared plus 1 equals secant squared. Now the main Pythagorean identity is just this one, sine squared plus cosine squared equals 1. If we divide every term by cosine squared, sine squared over cosine squared over cosine squared, 1 over cosine squared, we actually get the second identity. Tangent squared plus 1 equals secant squared. And if we divide the original identity, sine squared plus cosine squared equals 1, by sine squared, then we get the last one. Sine squared over sine squared is 1. Cosine squared over sine squared is cotangent squared. And 1 over sine squared is cosecant squared. And so we get this last identity. So if you know the first identity, sine squared plus cosine squared equals 1, and you divide by sine squared or cosine squared, you can get the other 2 identities as well. So again, a simple way of understanding how to get, memorizing one identity and then knowing how to derive the others can be very simple and helpful. Okay? Quotient identities. For all angles theta, for which the denominators are not 0, the following identities hold. Sine over cosine equals tangent, and cosine over sine equals cotangent. Now let's try to look at, if we're given one of the functional values, how we can find the other functional values from the identities. In this problem, we're trying to find sine theta and tangent theta, given that cosine theta equals the negative square root of 3 over 4, and sine theta is greater than 0. Well, first of all, we know that sine theta, since sine theta is greater than 0, this means our y value is also going to be greater than 0, which means that we are in quadrant 1 or quadrant 2. And since we know that cosine is negative square root of 3 over 4, we know that our x value is negative, which means now that we know that our angle, our theta, is in quadrant 2, where x is negative and y is positive. Since we're trying to find sine and tangent and we're given cosine, our first identity that's really simple to use is the Pythagorean identity, specifically that sine squared plus cosine squared equals 1. So we're just going to plug the value in for cosine and then solve for sine. So we get sine squared theta plus cosine squared. And remember, cosine is negative square root of 3 over 4. We're going to square that, and that this must be equal to 1. So we're going to multiply this out, square this out, and we get 3 over 16, positive 3 over 16. We're going to subtract that from 1, and we get sine squared theta equals 13 over 16. If we take the square root of both sides, we get plus or minus the square root of 13 over 16, which gives us the square root of 13 over the square root of 16, which gives us the square root of 13 over 4. Now, whenever we're finding a square root of a square, we have to consider the positive and negative values, but we were already indicated that the sign has to be positive, so we're just going to select the positive square root. So we've already figured out our first value, which is sine theta equals the square root of 13 over 4. Okay, so we found sine and we need to find tangent. Well, remember, tangent is equal to sine over cosine. So we can simply put these two fractions in relationship to each other. Tangent theta equals sine over cosine, so we plug in the values, the square root of 13 over 4, which we just calculated, divided by negative square root of 3 over 4, which was a given. Now, you may forget how to do this, and this is really simple. So we take the numerator divided by the denominator, which is the numerator times the reciprocal of the denominator. And when you do that, you'll see that the 4's cancel out and we get negative square root of 13 over 3. And what we want to do here is we need to rationalize by multiplying by the square root of 3 over the square root of 3, and we get our answer. When you're taking the roots, make sure you choose the correct sign whenever you take a square root or any root, right? And you get that correct sign by knowing what quadrant you're in, knowing what the x and the y value should be. All right, let's try another one. Find sine theta and cosine theta given that tangent theta equals 4 over 3 and theta is in quadrant 3, okay? So here we know that quadrant 3, sine is negative, y is negative, cosine is negative as x is negative, and so that just gives us some insight into what's going to happen as we move forward. Now, it's tempting to say that since tangent equals sine over cosine and tangent equals 4 over 3, that maybe sine theta is 4 and cosine theta is 3. But that would be incorrect. And we could even say, oh, well, since they're both negative, then sine is negative 4 and cosine is negative 3. But that doesn't necessarily work out as well. And remember also, it's not even possible for that to be true because sine and cosine have to be between negative 1 and 1. So we've got a little more work to do than just that. Okay? Well, remember that tangent squared plus 1 equals secant squared, and secant squared is the reciprocal of cosine. So if we find secant squared, we can reciprocate that and then find the value of cosine. Well, tangent was 4 over 3, so tangent squared is 4 over 3 squared plus 1 equals secant squared. And when we do the math here, we get 25 over 9 equals secant squared. And so when we take the square root of the numerator and the denominator, we get 5/3 plus or minus 5/3. And remember that since cosine is going to be negative, its reciprocal will also be negative because we're in quadrant 3. So since secant equals negative 5/3, then cosine is going to be its reciprocal, or negative 3/5. We can now use the fact that we have the value for cosine and use the original Pythagorean theorem, sine squared plus cosine squared equals 1. or we can find sine squared by subtracting cosine squared from 1. And here we just do the math, and we get sine equals -4/5. Again, choosing the negative square root of 16/25 because we knew that sine was in quadrant 3 and that sine in quadrant 3 is negative. All right. We could have also simply taken the fact that cosine is, or excuse me, we were given the tangent, which was 4/3. We could have graphed it like we did in the last section and then figured out all of the values using x, y, and r. And so this might be a little bit simpler for you to do, but I wanted you to see both ways of solving it using identities. And of course, we did many of these in the last section. So this is the end of this lecture. Good luck with your homework.